So this is part 2 of zeros of polynomial functions. So we're going to be picking up where we left off yesterday from the factor theorem. Okay? So the difference today is that I am not giving you one of the factors like I did last night on the homework, like on number 10 right here, x plus 2. I'm not giving you x plus 2. So you have to come up with all your own zeros to check and plug in. So that means like -7 might work, 14 might work, 10 might work. You just have to check all the numbers, right? Let's hope not. That would take a long time. That's why someone came up with this rational zero theorem. Rational zero theorem states if we have a polynomial, this is the general form for a polynomial, and we're going to be really interested in this a sub n up front and the a sub 0 in the back. If it has integer coefficients, then every rational zero of f of x has the form p over q. So our very first step today, I'm going to say find all your p over q's. Okay, and what I mean by that, when you find your p's, p's are going to be factors of your constant term. Your constant term is this n term back here, a sub 0. Okay, while q is the factor are going to be the factor of your leading coefficients, which is a sub n. A sub 0, yes. Well, it's like a 6. Sorry. I'm nervous going live like this, recording in front of you guys. So there's going to be a couple of homework problems tonight. I plan on putting one of these on your quiz Monday where you just have to list the potential zeros. What might be a 0? Okay. So instead of plugging in every number, when we're just listing the potential zeros, I just want to look at the last number right here. I'm going to call that the p. And I want to look at the first number right here. We'll call that the q. And what I'm wanting to do is I'm wanting to take all my p's over my q's. I want to take all the factors of p first. So what are all the factors of 10? 1, 2, 5, and 10, right? Can we agree? There's no more factors of 10. Nothing else that's a integer that I can multiply together to give me 10. So -1 times -10 is, we have to include all the negatives on these as well. Good. So look at my q up front. My leading coefficient is -1. So q is going to be all my factors of -1, which is what? Just plus or minus 1. So I don't have to check every number I can think of to see if it works. If it's a rational number, it will be in this list, and that will be the zeros of this function. Okay. All right, you guys try part B, and then check with your neighbors, see if they got the same thing. So all of these would be my zeros. Okay. So what that means is on this one, since I have two numbers on bottom, 1/2, 1/2 might be a 0. I could check that. All right. And so this is the first step in finding zeros. I call it without a net, without them telling me what one of the zeros is. I'm going to find all the rational zeros of the function. And then I'm going to use synthetic division to find the possible zeros. How am I going to know if the 0 I pick, or the potential 0 I pick, is a 0? You're going to get a 0 right here in the remainder, correct? Just like we did yesterday. If I don't get a 0 in remainder, bad news. You got to go try something else. So I just discard the candidate. I just keep repeating step 2 until I get everything down to a quadratic. All right, thanks to all of August, we got to be pros at factoring quadratics, completing the square, quadratic formula, any of those that I want to use to find the remaining zeros. So I have 3 examples. try to get through this first one together. So this one just says find all the zeros. Okay, now I'm going to tell you, today they're all going to be real zeros. Tomorrow we might get into some complex ones. Okay, so first step is just my list of p's over q's. So what's my p's up here? Okay, and my q's? So we don't have very many on this one. I think the first one in the homework's your p is factors of 24. So yeah, you're going to have a long list, plus or minus 1, plus or minus 2, 3, 4, 6, 8, 12, 24, so forth all the way out. So we don't have very many to check on this one. So next what we do is we just choose one. Now I really don't know which ones work, which ones don't. I've worked it a couple of times today, so I've got a pretty good idea. But when I worked with this for the first time, I made these slides a long time ago. So I would just be guessing on this like you guys. Maddie's looking pretty lucky back there. Look at her. You see Maddie? So Maddie, I want you to choose one of these. Now they're divided by 1, so the q doesn't really play a factor in this because 1 divided by 1 is 1. So I want you to choose 1, -1, 3, -3. We'll see if it works. -3. All right, so I'm going to plug -3 in to see if I get a 0 down here. So I drop the 1. I multiply and add. Multiply and add. Maddie had a very good guess on that. All right, so she got -3 to be one of my zeros. So that's one of my answers. I'm going to come back and circle it so I remember. So now, my depressed equation that I'm working with from this is x cubed minus x squared minus x plus 1. I don't have it down to a quadratic yet. Now, I will tell you this does factor. This is a special factoring pattern called factor by grouping. If you know how to do factor by grouping, please go ahead and do that. That'll give you the rest of your answers. But suppose we don't know how to do factor by grouping. I need to go about this again. Before I get going, look at my P down back here. I can revise my P over Q list. All right, the P doesn't have 3 as a factor anymore, does it? So that means 3 and -3, they're not going to work anymore. So I'm down to a 50-50. Dr. Yak, what are you thinking? 1 or -1? -1. All right, so I'm -1. And I'm wanting to work with my depressed equation. So I'm going to use my coefficients from this last one that I just did. Wow, that's a lot of 1s and 0s. It's going to look like binary, I think. Oh, there's a 2 that slid in there. Why is it so hard? Okay, here we go. So, Dr. Yak, with a good choice of -1, it worked. Okay. So now I write down what I am left with. I am left with x squared minus 2x plus 1. I've knocked it all the way down to a quadratic. We should be pros at solving this. Not only can we solve it, we can factor this. What are 2 factors of 1 that have to give me -2? X minus 1 and x minus 1. So I get x minus 1 equals 0. And x minus 1 equals 0. So x equals 1, x equals 1. So Dr. Yak, Maddie, they both could have said 1 as well, and it would have worked. And yes, I wrote that out twice. I need both of those answers. Because how many answers am I supposed to have? 4. How do I know that? The degree of my polynomial is a 4. They should match up. So that means 1 is an answer on this polynomial twice. We'll get a special name for that next week. Okay. Shay. If I did the factor by grouping on this, it would have spit out the rest of them. Yep. That's perfectly fine. Do I know? Yeah. Good. Most of the time, I'm going to try to make it so the grouping won't work. Like this one, I've already knocked it down to a cubic. polynomial, and the factor by grouping does not work on it. So I'm going to make it so you need to do this polynomial long division. So let's try this one. Actually, if you're watching the video, you guys go ahead and try this one on your own. Go ahead and list out your P's over Q's and make some guesses on it. So obviously, if you're watching this video, you do not want to take any of my 6th-hour pre-cal students to the casino with you. They are not very good at guessing. Stay away from the roulette wheel, right? So negative 1/3 ended up working, and then we were able to factor this down. Let's work one more together. End of this one's going to be a little bit weirder. Yep, that's what we're going for. Man, a lot of erasing. Let's try to guess better this time, guys. I got to keep this under a certain amount of time for YouTube. Right? I don't know. Wait, we're going to go for 24 hours. So if you're watching this at home, go ahead and go get something to eat. We'll be back. All right, so Annie watches them. So Annie's going to, hey Annie, we miss you. Get better soon. All right, so first up, we need my P and Q list. So I've kept it pretty small this time, thank goodness. We're not guessing very well. You think it's negative 2/3? Are you just, you guessed last time. Try 1? Let's try 1. Let's try something nice first. Yes. I'm going to let the world see what bad guessers you are. Oh, we got our 0 a little too early on that one. All right, so 1 does not work. All right, Dr. Yak wants to go 1/3. Three. 1/3 of 3, that's 1. Oh, there's a fraction. That's not going well. Negative 2. We drop. We multiply. Why is that hard? Multiply. Oh, not quite. Got to X out my 1/3. Which one you guys want to do? Negative 1/3 or negative 2/3? Do the negative part. All right, negative 1/3. Negative of Parker's answer. That's true. Negative 1/3. 3, 4, negative 7, 2, 3, negative 1, 3. That's good news. Oh, not quite. This is the worst anybody's guessed all day, just so you know. 3rd hour came in, and they guessed the right one right off the bat every single time. They got to the homework, and they were guessing wrong. They were saying, we're doing it wrong. We have no idea. I'm like, no, you got really lucky on your guesses. Negative 1. Have we done negative 1 yet? It's not that many to try. It just, nope. Holy cow. Negative 2/3. Negative 2/3. Negative 2/3. Alright, so what does this give me? Negative 4/3. That's not good. It's not good. 2. We already did 2. 2. About 2. Regular 2. What is wrong with you guys? I'm picking my own. Oh, there it is. Good job, guys. No thanks to my 6th-hour class. All right.
Thanks for nothing.
All right. So this is a 0 right here. I finally get my depressed equation, pretty much because I'm out of boardroom, so I had to make my own guess. 3x squared minus plus 6x minus 3. All right, again, I always check for that GCF first, all right? Demi's showing me 3 in the back. Let's divide everything by 3 right here. All right, and then I'm looking for 2 factors of -1 that add up to give me 2. Impossible. I'm supposed to have 3 answers. Quadratic formula. Or complete the square. Completing the square would not be hard on this. We got a nice even number right here in the middle. Let's complete the square on it. Mason, won't you do quadratic formula and see if we match answers, okay? So completing the square. If you want to, if you see that you're going to do quadratic formula more, go ahead and do quadratic formula. That's perfectly fine. But I would complete the square on it. So I left a hole right there to complete the square. What do I need in this hole? 2 divided by 2 is 1. 1 squared is 1. Okay. So that gives me, we've done that a lot, yeah. That gives me a perfect square trinomial on the left side. So x plus 1 squared. Okay, on the right side, that is 1 plus 1 is 2. So now I take the square root of both sides. Yeah, x plus 1 equals plus or minus the square root of 2. Subtract 1 from both sides, and those are my other 2 zeros right there. They are not rational. They will not come out in my list because of that square root of 2. So therefore, 2/3 was the only thing in my list that was going to work that time. The only thing. The other 2 are irrational, so I have to do this working down, which makes it, I want you to see how important it is to work with this depressed equation right here. All right? Otherwise, you will not be able to get those last 2 zeros. Okay? How do you complete the square? I took this number, this 2 right here, half of it, and then squared it. Gives me a 1. Okay, this